Yeah.
Oh. How long is it gonna take?
Well, judging by the 5.11 notes, jeez.
Well, we also have what?
4 weeks after that?
Yeah. So I mean, we're right there at the end, anyways. So what we're covering today, or what we're starting with chapter 5, is rational exponents and rational functions. So we're talking about radicals, square roots. Now the first thing we're looking at is the square root of 64 and the cubed root of 64. Now which one of these is bigger?
The square root of 64.
Because what is the square root of 64? 8. Because when we take the square root, we're looking for a number times itself. Cubed root of 64, we're looking for what number times itself? 3 times is 64. And what is the cubed root of 64? Because 8 times 8 is 64. Well, 4 times 4 is 16. And 16 times 4, multiplied again, 4 carry the 2, 4, 5, 6 is 64. So yes, square root of 64 is indeed bigger than the cubed root, because each time we increase the index, the number inside that little v, we're looking for a number times itself that many more times, which is going to make it smaller. Because if we said the fourth root of 64, fourth root of 64 is fifth root of 64 is, as we can see, it keeps getting smaller. So the sixth root of 64 is indeed 2. So it doesn't have a set pattern, but it does get smaller each time we increase the index. Now, something we've learned already is that the nth root of a is equal to a to the 1 over n. So we can turn a radical into a rational exponent. Now, the n goes on bottom of the fraction. So our index, our root, what we're taking, goes on bottom. And actually, the exponent goes on top. So the nth root of a to the x is the same as a to the x over n. The nth root of a to the x is equal to a to the x over n. Questions on this so far? And this is kind of nice to know. It explains some things that we've been using or you've used before that may not have made a whole lot of sense. Because if we took the square root of a squared, we know this is just a, yes? Now if we write it as a fractional exponent, the root, our index, is 2. Even though we don't write it for square roots, it is 2, and it goes on the bottom. Our exponent inside is also 2, and it goes on top. Well, 2 over 2 is, so we just have a to the first or a. That is why when the index, our root that we're taking, and the exponent are the same, they cancel each other out. Because it doesn't matter what it is. Because we could say 864, the 864th root of a to the 864, well, that's still just a, 864 over 864, which is just a. This is why it cancels out, why it simplifies to 1. All right. Questions on this here? We're ready for the next one, or first part of this here. Well, we've been doing this here, and it really doesn't tell us much, and I'm definitely going to probably remove these next time. Actually, we're just not even going to look at it, because there's not a whole lot to that part. Because what I want to look at is this here, is being able to switch from one to the other. So our square root of 5 to the third, well, square root of 5 is the same as 5 to the what power? Well, the index number inside our radical is 2, so it goes on bottom. The exponent here is 1. So the square root of 5 is the same as 5 to the 1/2. Questions on how we got to this here? Powers of powers multiply, so our 1/2 and 3 multiply together to give us 5 to the So we're saying that we're multiplying 5 by itself 3.5 times. Now, if we wanted to see what this value is, we can do this in the calculator. 5 to the 3/2 is 11.180333989. Now, what we started with was square root of 5 to the third, which is the exact same thing. Now, rewriting it sometimes can help give us a nicer number. It can simplify better that way. Sometimes it doesn't. But these are different ways to be able to find this. Questions on this here? Because this was 11 point.
Oh, so we got the.
Well, I'm just going to write it down. 11.1803. So we'll put that there. But we have.
So 11 would be the answer?
11.18, and if we do evaluate, especially with these here, I'll specify where to round to the number of decimal places. But especially like last chapter with solving, if we do get something like x equals 5 to the 3/2, we can leave it as that, especially with solving. Does that make sense?
Okay, yeah. So say if I want to come to test or homework.
Because if it does say to round to a given decimal place, go on and round it. If it doesn't, leave it in radical form.
So I can, I'm just asking, like on the test, because I usually do it on the paper on homework, and just write it down so it looks neat. But on here, I can just put.
Yeah, because if it just said simplify, 3/2, one of those will go into detail there. If it's solving and doesn't ask to round, leave it in radical form. If it tells you to round to the third decimal place, round to the third decimal place.
So I can just say 1 equals 11.1.
Yeah. Yep.
I was just wondering if that was like part of the answer.
No, it's a little here nor there because the homework isn't actually going to cover these.
Oh, cool.
The fourth root of 4 squared. If we wanted to rewrite the fourth root of 4, is 4 to the 1/4. Because our 1 would come from our exponent, and the 4 would be the index. Now, this is kind of going to be a little bit nicer because we can't take the fourth root of 4 because there's not a nice number that multiplied by itself 4 times is 4. It just doesn't work that way. Here we have 4 to the 1/4 squared. Our 1/4 and 2, powers of powers multiply, so 1/4 times 2 is, because it'd be 2 over 4. 2 over 4 is 1/2.
I keep wanting to divide or multiply the 2 by both.
So we multiply by 2 because it's the same as saying 2 over 1. Numerators with numerators, denominators with denominators.
Wait, so we divide the 1 over 4 by 6?
Because 1/4 times 2 is what? Because it's 2/4. Well, 2/4 is 1/2. Well, so 4 to the 1/2, yes? Well, if we want, we can say 4 to the 1/2 is 2. That seems interesting that it simplifies like that. So if I rewrote 1/2 as a radical, 4 would be inside, yes? The index would be 2. So the index is 2, and the number is 1. So really we're taking what? The square root of 4. What is the square root of 4? So some of them do simplify nicely. Because if we looked at, say, the fourth root of 4, we do get this number, and when we square it, we do get back to 2. Questions on these here?
I'm too focused on cooking this. I got all this jelly out. I hate jelly.
The cubed root of 9 squared. Well, we could rewrite the cubed root of 9 as 9 to the what? 1/3. And our square, we multiply, powers of powers multiply, giving us 2/3. 9 to the 2/3. Now, we could plug this in and see what we get. .3267748, so 4.327, but it doesn't give us a nice number. So if it did ask us to round, we would do that. If not, we can leave it as 9 to the 2/3. But again, this is less about getting to the answer and more about us seeing how we can switch from one form to the other. Is this questions on this here?
So we can leave that answer as 9 2 3.
Yeah. I mean, this part, it's not so much what we're going to end up doing. It's just I want you to be able to switch from one to the other. Because I think we're going to move on to some of these. Actually, we're going to jump. Yeah, we're going backwards. We're going to do 3 of these where we're going backwards. They give us the fractional exponent. We're going to go to the radical. So 8 to the 2/3. Yeah, that's the next thing. So there's a few ways we can do this. One is we can say that this is 8 to the 1/3 squared, because we always dealt with the fractional exponent first and then dealt with power. So we can break it up here because powers of powers multiply. So what we're looking at this here is the 3rd root of 8 squared, because our numerator, the 1 goes with the 8, and the 3 on bottom is our index. So we have the cubed root of 8 being squared. And that's it. Now we could try to simplify it, because if we're looking for the cubed root of 8, we're trying to see what times itself. 3 times is 8. And luckily for us, there is a number for that there. And our 2 squared is 4. Mm-hmm. If we look at the next one, 6 to the 5/2, we could say that this is the same as 6 to the 1/2 to the 5th. Well, our 6 to the 1/2 is in radical form, so our 6 would be inside the radical. The 2 would be our index. Now, with square roots, the 2 is understood, so we can write the 2 there as the index. We don't necessarily have to because it is understood. 6 to the 1st to the 5th. And really that's about as simplified as we get without plugging it into the calculator. Now this one here won't simplify further because the square root of 6, is there a number multiplied by itself that gives us 6? Well, no. Not a nice number. It'd be irrational. And the 5th power doesn't help. Okay. Questions on this here? Yeah. We'll look at one more, 12 to the 3/4. So we can say this is 12 to the 1/4, because our 4 on bottom gives us our radical. Now the index is the one on bottom, which is 4. So we can say the 4th root of 12 to the 3rd. Now we did have this at the start. nth root of a to the x is equal to a to the x over n. So it is true that we could say that this is the fourth root of 12 to the third. These are the same thing. The 3 being inside or outside the radical will give us the same answer with our real roots. Questions on this here? So we good with this here? 12 to the 4, 3 fourths is this here. Okay. We're going to skip that one and we're going to look at these here. Evaluate each expression without using a calculator. What that really means is that these are going to work out nicely. Four to the 3 halves. And again, we can do this in different ways because we can do it like we've been doing and saying that this is 4 to the 1/2 cubed. Well, 4 to the 1/2 is the same as the square root of 4 to the third. Well, we know the square root of 4. Square root of 4 is what? 2 to the third power. 2 to the third is? Because we want to find different ways to simplify it as best we can. Now, as we said just a minute ago, 4 to the 3 halves is the same as the square root of 4 to the third, because this is the same thing. Now, 4 to the third. 4 squared is 16, and 16 times 4 is 64. So we could say that this is the same as the square root of 64. And the square root of 64 is? We do get to the same answer. But here, it might be a little bit easier to take the square root first and then cube it. Let's look at B. 32 to the 4/5. Well, we could say this is the same as 32 to the 1/5 to the 4th power. Because we could take the 5th root, because this is what we're going to be doing, the 5th root of 32 to the 4th. And we could do it like the previous one and take the 5th root of 32 to the 4th power, but we'd also have to figure out what 32 to the 4th power is. That's going to be a probably really big number. But if we take the 5th root of 32 first, what do we think times itself 5 times is 32? Power, take a guess. Well, there is something. Because it's not 1.
I'm going to say 6.
Because 6 squared is 36. 6 to the 4th is 216. Well, we have to do this 2 more times.
It's going to be a decimal.
It's actually going to be
2.1.
3.3.
Yeah, there is a nice natural number.
Yeah. 2.
Is it just 2?
Because 2 squared is 4. 2 cubed is 8. 2 to the 4th is 16. And then 2 to the 5th is?
Yeah, I get 3 and I got like that.
81. Or no, it's going to be
9 times 9.
273. Now 2 to the 4th is?
16.
Yeah. So here, simplifying the 5th root first made this easier to work with, and then we can put it to the 4th power. Because 32 to the 4th is this number here, and we could take the 5th root of 10, 4, 8, 5, 7, 6, and we get the same answer. But some of them are a little bit easier to calculate than others. Questions on these here?
Didn't we just put that in the calculator?
Mhm. Yeah, but we want to evaluate them. Trying to do these without the calculator. 625 to the 3/4. Now, we could evaluate or kind of break this up as 625 to the 1/4 to the third. And we're taking the 1/4, so that's the same as the what? 4th root of 625 to the third. So we're looking for a number that multiplied by itself 4 times is 625. If we're to take a guess, what number do you think multiplied by itself 4 times?
I guess 5.
5. So 5 times 5 is our first one, which would be 25. So that's 5 squared. 5 cubed, we multiply by 5 again. Goes 5, carry the 2, 10, 125. So that's cubed to the 4th, 5, carry the 2, 10, 12, so 2 carry the 1, 5 and 1 is 6. So the 4th root of 625 is indeed 5. Now, 5 to the 3rd power is it goes squared, cubic is 125. Questions on this? I was doing that so we can see the calculations. Because if we're doing it purely without a calculator, we have to do some of those on our own.
I could use that little thingy that you taught us.
The factor tree?
Yeah, that thing.
Because that is a quicker way to get there. 49 to the 3/2. Well, really looking at 49 to the 1/2 to the third. Well, 1/2 is just the same as the square root. Because 1 goes inside, 2 goes on the outside, our index. Square root of 49 is?
7.
So now we're looking at 7 to the third. Well, 7 squared is? So we just need to multiply by 7 one more time. 3 carry the 6. 7 times 4 is 28. Plus 6 is 34. So 7 to the third is 343. Questions on these here?
So if it's 49 to the 1/2, it's always just going to be square root.
Yep. Because 1/2 is our square root. And that is somewhat nice to know, especially if you're taking the square root of a number or having to type it in. Sometimes it's easier to type it in as a fraction than it is as a radical. Questions on this here? If our exponent is less than 1, the number that we end up with is smaller than what we started with. If our exponent is greater than 1, the number is bigger. It's going to work that way every single time. Because if we looked at, say, 7 to the 1st power, well, that is 7. So if it's bigger, so 7 squared is 49. Because if the exponent's greater than 1, the number should end up being bigger than the number we started with. Questions on these here? You ready for the next part? Okay. Real nth root of a. So we're talking about taking a root, applying a root to a value, given value. Now we'll start with odd. N is odd. So we're talking about, say, taking the cubed root, 5th root, 7th root, going on up. Or n, that index is odd. Now we have one of 3 cases. The first, if the number inside of this is negative. So we can say -8. If the number inside the radical is negative, we have one real root. Exactly one real root. So when we have an odd index, so the cubed root is -8, we have one real root. We good with that there. Now if the number inside is 0 with an odd root, we have one real root. And if the number is positive with an odd root, we have exactly one real root. Not too bad. Because if the index is odd, so 3, 5, 7, 9, 12, or 9, 13, 15 going on that way, well, we're either going to have one real root, or one real root. Because if the index is odd, we only have one real root. Now, if the index is even, we're talking about the square root, 4th root, 6th root, 8th root, 10th root, 12th root. And the number inside is negative. We have no real nth root. Because if we took the 4th root of negative 16, there's no real nth root, because the 4th root of 16 is 2, but this here would be plus or minus 2 I. I is not real, because if we're looking specifically for the real root, I is not a real number, so we wouldn't have a real root for it. Now, if we have an even root and the number inside is 0, well, we have one real root, and that number is 0, because 0 cannot be positive or negative, it's just 0. And if a is greater than 0, a is a positive number, we have two real roots. We have to add that plus or minus. Because if we looked at the 4th root of 16, we do have plus or minus 2. Because 2 to the 4th is 16. Negative 2 to the 4th is also 16. So, let's look at this next part here. Find the indicated real roots of a. So we're looking for the nth root of a. Now for our first one here, our n value is 3 of negative 216. So we're taking the cubed root of negative 216. Now since the index, our root, is odd, we can have one real root, or one real root. That's all we can have. And the nice thing with these, we can take 3 cubed root of negative 216, which is and that's it. Questions on A? B, n is 4, a is 81, so the root we're taking is 4, and the number inside is 81. Since our index is even, we could have no real roots, one real root, or 2, and it's based off the number inside. Now, since the number inside is greater than 0, it is positive. It means we'll have 2. We'll have to add the plus or minus. Now, at this point here, we can grab the calculator and say 4th root of 81, which is 3. So our answer is plus or minus 3. The calculator will give us the positive solution. It won't give us the negative, but we have both. Because really what we're saying is x to the 4th is equal to 81. We're solving it by taking the 4th root. Questions on this here? We're ready for the next one. N is 4, a is 16. So here we're looking for the 4th root of 16. Now since we have an even root, we're going to have none, 1, or 2 solutions. Since the number inside is greater than 1, or greater than 0, we have 2. The only time we'll have 1 is if the number inside is 0. If it's less than 0, we have no real nth roots. Now the 4th root of 16 is 2. We can plug that in a calculator also. I believe I stated that just a few minutes ago. We good with these so far? Let's look at the next one. So the number inside is negative 49. Our index is 2, yes. Since the index, what we're taking this, our n value is even, and the number inside is negative, we have no real nth roots. Because here we're not looking for what the actual square root of negative 49 is. We want the real roots. And because there is no real root for the square root of negative 49, we just put no real nth roots. That's it. Because it would be 7i, plus or minus 7i. Yeah. Since it's imaginary and it's not real, here they're just wanting the real root. We ready for the next two? N is 3 and a is negative 125. So we will have one real root. We just need to figure out what it is. Now, I will tell you this, with odd roots, if it's cubed roots, fifth roots, if the number starts out negative with it, it's going to end up being negative. And we can put this into calculator 3. Well, let's go on and put, because the cube root of negative 125 is negative 5. If it would have been positive, it would have been positive 5. Yep. And the last one, n is 5, a is 243. So we're looking for the fifth root of, thank you. Since it is odd, we will have exactly one real root. And the fifth root of 243 is 3. Questions on this here? 5 through 16.